So good afternoon. I'm going to talk about the Irish Drug Delivery Network cluster again, funded by SFI for the last 5 years. And it's a collaboration between 3 schools of pharmacy and UCD, Economy Institute, as well as 4 or 5 biotech companies. And we've been working in the area of, it's a consortium doing novel delivery systems with translation potential. That's the key bit here. We're interested in actually taking systems and improving them. No matter where they come from, whether they're from the academics or whether they're from the companies, we're trying to make them better and translate them forward in preclinical research. So we're trying to provide delivery solutions for some of the companies out there that have some brand new interesting molecules. Some of the startup companies have new molecules and they're very interested in getting them to the right part of the gut, for example, or getting them to permeate the gut wall to make them into oral forms. And also device companies, there are some fantastic devices out there and they need a bit of help in characterizing some of the materials that they want to put into those devices and see that they emerge intact. One of our main outputs is to train researchers. So we have PhDs who've come from the companies and they're in the universities studying for a PhD or a master's. And then the idea is that they return back to those companies, hopefully, at the end of that program. So that's one part of it. And we also have done a program of continuing professional development with the partners we work with. So we'll go in and design bespoke courses for some of the companies that are in the cluster and indeed for some of those outside. So in detail, the kind of work we've been doing are mainly on oral peptides, which is a big forte of my own, to try and enable them to permeate the gut wall in a stable format. We also then developed an offshoot into developing nanoparticles for intra-articular delivery in arthritis. And on the other part, on another side of the cluster, we've been developing particles for pulmonary delivery of peptides. And Trinity and RCSI are particularly strong in this area, and Sally Ann will talk more about that in her talk at the end. We've also been working on some of the new molecules that were mentioned this morning, things like siRNA. Delivery is still the big issue for those molecules. Making dosage forms for them involves an understanding of chemistry, good bioassays, and really good characterization of all those new molecules. So this is different. It's not manufacturing. This is research at a level behind that, but it could become very big. Okay, a little bit of detail on our industry partners. So we work with Aerogen in Galway. They make these fantastic little Aeroneb devices for pulmonary delivery. And again, Sally Ann will do those in detail. We also work with Genzyme in Waterford. This is our foray into the processing area, where they're funding a student at UCC to work on characterization of a process and to improve it. We also have been opportunistic in that we've worked with the agencies in that EI and IDA brought a US company called Arch, which is run by Irish Americans. They brought them to us and said, can you help here? They've got a really interesting peptide that stops bleeding. It's not an anticoagulant agent. It forms a barrier that will prevent bleeding in laparoscopic surgery. So we've been developing a proper formulation and improving the chemistry behind that process. And it's been a lot of fun involving labs from all over the country. Sigmoid we're going to hear a lot about in this session. They have oral dosage forms for oral peptides in particular. And they've been working with me, also with Cormac Taylor, who's in the second talk, and we'll do that in some detail. So I have examples of the Aerogen technology and Sigmoid in a little more detail. So Sigmoid has a liquid emulsion drug delivery system, and the idea here is that they have beads containing emulsions that are coated, and they put them in a gel capsule, and the idea is that they will release in different parts of the gut, and they can control that in particular for delivery to the colon. And that's a really good place to release drugs for treatment of inflammatory bowel disease like Crohn's and colitis. And Monica will give a little bit more detail on the kind of formulation that goes into that. So why are Sigmoid interested in us? They're interested in us because we have these bioassays which we've worked on for over 20 years. So we have a reductionist approach where we're able to grow intestinal epithelial cells as monolayers in tissue culture, the CACO2 system, which will be very familiar to many. We've also are able to put tissue, intestinal tissue from rats, mice, dogs, well I'm in a vet school, and also hospitals. So we're able to get colon cancer patients to volunteer to give normal pieces of tissue so we can look at drug transport in the forward and back direction, corresponding to the food and the blood side. We then do animal work in rats. We're able to look at different parts of the intestine in these rats under anesthesia. We will then do it in a single pass perfusion format, sending the formulation through in a single pass across the intestine to see what gets delivered to the blood. And then we do oral gavage work, which again, Monica will talk about in a little bit more detail on one of their formulations. A little bit of data. So with Sigmoid, we were able to work on a particular enhancer. So this is a drug or an excipient from the pharmacopoeia. And we were able to show that this actually enhances the passage of drugs across the colonic epithelium from the blood side to the basolateral side. And then Sigmoid were able to make their beads. They put what was in here into their beads, and they're able to get a delivery of calcitonin, which is a very important peptide for osteoporosis, which is normally injected or given by the nasal route. So it would be really useful to try and develop an oral calcitonin for osteoporosis and other diseases. Okay, so with Aerogen, we've also worked on their device. They have a fantastic device, and they're looking for new cargoes and combination products, because that will allow them to extend a patent life and so on. And they have a very, very nice device, and Salian has been working with them. And again, we're using calcitonin as a peptide example. They're able to show that what comes out of the AeroNeb device for pulmonary delivery, that it's intact as shown by HPLC and also size exclusion chromatography. What you put in, you get back in the same format. And that's the kind of research that Aerogen are interested in doing with us. Okay, then we had a lucky fortuitous happening when we work with some people who are interested in inflammation in the university, and we worked out that calcitonin, not only does it work as an anti-osteoporosis agent, but it actually dampens inflammation. And we proved how this works at the level of an orphan receptor, which I can't go into today. But then we worked with our Trinity colleagues in which we combined hyaluronic acid, which is a sugar normally found in your joints, as a lubricant. We combined the two together using a polymer, chitosan, made an electrostatic nanoparticle, and then we started injecting it into joints of inflamed animals. So this isn't trivial, as you can imagine. So we had to go off and learn how to do this. So SFI funded one of our postdocs to go and learn the animal model. This is a mouse model of inflammation in London in Mauro Peretti's lab. This is the best money we ever spent, or the state ever spent, in this area. And we were able to show that the nanoparticles were able to dampen down inflammation in this acute mouse model of arthritis. And it was nearly, in fact, it competed very well with steroids, which would be the gold standard. And we're very aware that steroids and hyaluronic acid, they're normally what you get if you go in for a knee injection for osteoarthritis. And as everybody knows, they're actually not very good. This is an area of real unmet medical need where you might get benefit for a couple of months and a bit of benefit on your pain score. So what we did in these animals, we were able to show that when we injected in a one-time injection into the joints of into the knees of these mice, we could dampen down the inflammation in terms of the knee diameter, and also we got reformation of some of the cartilage in the joint, whereas this is the control messed up cartilage in the sick animals. Okay, final example. We worked we're working on siRNA delivery, and we work on cyclodextrins in the cluster, and this is a forte of the chemistry department in UCD, and also with our colleagues at UCC who are really good at formulating this stuff. So cyclodextrins are approved for injections, and they're really good solubilizing sugars. So what the guys have been doing is they've been making new forms of cyclodextrin, putting lipids on one face of it, and putting new charged molecules on the other. So if you think of these like inverted lampshades, where we're able to get siRNA to be entrapped between a bunch of these, and then we're able to inject them. So some really novel work was done by John Crine at UCC in Cork, where they were able to use a mouse model of Huntington's disease. This is a well-established model where this mouse has the defective Huntington disease gene, and within about 3 months, they start to develop epileptic type syndrome, and they start to lose gait, they get behavioral changes, and they get neurochemical changes in the brain. So what we did was we injected our siRNA against the aberrant Huntington gene, and we were able to show a reduction in gene expression from injections into these mice. So the PhD who did this, he then did a rotarod test. So this is a standard test for Huntington's in these mice. So the idea is that these poor mice will cling on for dear life normally, and they'll cling on better if they're healthy, and if they're sick, they start falling off much more quickly. So it's not very nice. So the wild-type guys are able to cling on for 250 seconds, and we're able to show a benefit in terms of the ability of the mice that have received the siRNA in the cyclodextrin. They could in fact cling on better than the guys who are really sick. So we're going to do a lot more on this, but it's very exciting data. Okay, so the kind of outputs that we've had in the cluster, we like to think our PhDs are our best outputs. So we've got 13 of these that will be coming through by the end of the year. They do really well. They get lots of prizes from conferences. They get reported in the press. This is the cyclodextrin work was reported in Portugal because one of the students was a Portuguese PhD. And we've got our own students. This guy, Ed Walsh, came from Merion Pharmaceuticals. He's done a PhD with me in the ERCSET program, which is a fantastic program. I'd really recommend more funding into that side of it. It would be brilliant. And these guys like to come and work in our labs, and we like to think that we train them really well and that they will get job offers at the end of it. And hopefully we can keep them within Ireland at some point, or that they'll return at some point when they get even better training. So one of the outputs we really like to do is in terms of outreach. So we've done a lot of schools talks. I can tell you they're a lot more fun than these kinds of talks. You go into a transition year, and a lot of these kids are working out whether they want to do science or not. And these are very visual presentations with props. And they're a lot of fun for us to do, and we really feel that it's important work that we're doing there. And I know that outreach has now come into SFI's remit in the last few months, which is really good to see. Okay, so this morning it was mentioned, how do you leverage a cluster? So clearly we're in a bidding process for a new centre, but we're also working with other groups and we're trying to get funding from other areas. So we have a successful 7th Framework programme, which I'll talk about in a second, a project in that. And we're also preparing for the new Horizon 2020, which is going to be very industry focused and very translation focused. We've also worked with a number of the other clusters. So in particular, the National Functional Biomaterials Group, led by Abe Pandit in Galway, is a group that we have a collaboration with. And in fact, we formed a larger grouping to make our centre bid, which is called the Centre for Biomaterials and Biodelivery. Some companies don't like cluster formats. This was something we found out quite early on. Some companies are very conservative, like Novo Nordisk, and they prefer to work with us on an individual lab basis. So they sponsored a postdoc in the lab, and they brought their own staff over to learn some of the techniques that we had on offer. And they're fine about joint publications, so which has been great. And it's been a really nice linkage. And I would like to think that this is the kind of output that we also get from the cluster, even though they're not cluster members. And likewise, we have local Irish companies like Merion that have, again, sponsored individual people in the lab. And UK small companies like Critical Pharmaceuticals that are trying to develop nasal peptide delivery much better than the ones that are out there. They've been working with us as well. Okay, the EU grant, so it's worth 8.2 million over 5 years. The beauty of it is we were able to get 3 Irish partners from the cluster into this. And this happened because we were able to say, oh, you need this, we have them in the cluster. So UCD, UCC and Sigmoid are all in this oral nanomedicine project where we're trying to deliver recombinant insulin and 2 other peptide in a whole range of nanocarriers that are being developed across the EU. So within that, we've got a plan to try and screen out a whole lot of different formulations, nanoparticle formulations. And the beauty is that we have one skill in one lab, and that's all they do. They screen all these formulations head to head, and that's never been done in Europe at this scale before. And that's going to be done in this project, which has just started. Okay, briefly mention the centre. I don't want to say too much about it because we are in a review process. So we have combined 2 clusters. From the very first day of this call, we merged with the National Functional Biomaterials. And the idea here is to try and design new biomaterials that can be used as implants and also in medical devices, and use some of the drug delivery expertise that's in my cluster with some of the people in Abe Pandit's cluster that have a really good experience of using new materials and developing them with new chemistry. And we've raised 5 million, so we obviously hope that this has a decent chance that even if it didn't succeed on this round, maybe the next round, or maybe there's some other way of doing this to keep these companies interested. And then, as I just get towards the end, we have delivery research needs in other areas of Irish research. So we work also with Food for Health Ireland, which is funded by EI, and we've been providing oral bioavailability for that group in terms of some of the peptides that come out of natural food products, including milk. We're also starting to work with new startups with new molecules. So Ina mentioned Trino. So we will be working hopefully in the new centre with their new molecule for IBD to give them more information about the mechanism of action of how that drug works in the oral delivery bioassays that we have. CRAN is the nanoparticle group that is most established in Ireland. Their background is more in the engineering area. They're getting more now into the biotech area, and they're going to need to work with people who have been working with nanos in a long time more in the biotech area. And then NIBRT, Ian mentioned about NIBRT's capabilities. So I was out there for the tour. The tour is fantastic last week, and very enthused by meeting Ian and the idea of taking some of our projects when they reach a certain stage and maybe putting them into one of the NIBRT labs when they become a little bit more developed. That becomes really attractive. And likewise, the alimentary pharmabiotic people in Cork, with their probiotics, again, they may need some encapsulation and some formulation technology to try and enable that colonic delivery into the lower part of the gut that they would be interested in. Okay, so what are the benefits to the industry? So we've backfilled and provide mechanistic research data for their research. And that's really useful. It gives it a lot of credibility. We're doing stuff that they can't do in-house or they don't want to resource in-house quite reasonably. We're doing a lot on the education, on continuing professional development. And we're doing a lot in terms of taking industry staff and training them as postgraduates for PhDs and masters. And what have we learned? We learned that industry doesn't like dealing with individual universities. They like having a single mechanism, a single structure. So they come to the IDDN, they say, we want this fixed, or we want you to solve this. And they're not interested if it's done in UCD or Trinity or Cork. And they're not interested in dealing with 4 TTO offices. They want one way of doing this. And we've also learned that the startups around us are fantastic, doing really innovative stuff. The SMEs are also very creative. And also other academics who are being funded by SFI are coming out with some brand new molecules, and they need a bit of assistance on how to take them forward on a delivery aspect. In hooking up with the biomaterials people, we've opened up our knowledge of medical devices. It's brought my cluster into this area a bit more. We didn't know that much about it. And then finally, having a cluster, it gave us a lot more visibility with Enterprise Ireland and IDA. So that we're hosting, Shionogi are coming in from Japan on Friday, and we're making a presentation to them at UCD on behalf of the cluster. And then finally, having the cluster positioned us very nicely for that FP7 bid. And also I want to acknowledge Enterprise Ireland's help on that bid. They were really fantastic at enabling and brokering our efforts in that enterprise. And finally, these just the PIs in the cluster who have done all the work. Katrina at Cork, Salian, who you're going to hear about, Mark Devasell at College of Surgeons, both of these, and Karsten Ehrhardt at Trinity. That's it. Thank you. Thanks.